A recurring feature in some of today's spiritual and religious trends is the use of modern physics in its teachings and practices. This is most true of various New Age movements, most infamously with gurus like Deepak Chopra, who claim to incorporate ancient Ayurvedic medicine with quantum mechanics and assert an elaborate connection with physical concepts and consciousness. For example, according to Chopra, quote, "We are each a localized field of energy and information, with cybernetic feedback loops interacting within a non-local field of energy and information." Most physicists would rightfully say that these kinds of statements are either absurd, confusing, or even offensive. But it is interesting to note how many of the same religious influences of the New Age movement had some role in the history of the development of quantum mechanics. The historical record, including the writings and conversations of the most prominent names in physics in the first half of the 20th century, is littered with references to Hindu and Buddhist philosophies and even 19th century esoteric traditions like spiritualism and theosophy. Bohr, Heisenberg, Pauli, Born, these were just some of the names making these spiritual or ancient connections. Most famous of all may be Oppenheimer, especially his quotation of the Bhagavad Gita after the first detonation of his atomic bomb.
"Now I am become death, the destroyer of worlds." I suppose we all thought that, one way or another.
Why did so many famous physicists appear to be so interested in these dharmic traditions? Part of the answer may be that it was the trend of the time, at least for European intellectual elites. The first quantum mechanists were educated before the First World War, and were, more often than not, German. Many said they were influenced by the German philosopher Arthur Schopenhauer, who did much to bring Indian philosophy to the West in his writings, and whose popularity reached its height in continental Europe before the First World War. To many physicists, quantum mechanics represented a rejection of the traditional version of mechanical determinism that they had been accustomed to. The groundbreaking feature of the new theory was that it is probabilistic, meaning that there are things that strictly cannot be known until they are measured, and when combined with classical physical concepts like position and momentum, implies the profound phenomena of wave-particle duality or entangled action at a distance. In a probabilistic universe, there were certain features of a physical state which were not just hidden before measurement, but inherently indeterminate, and only become physically meaningful after a measurement is made. A number of greatly influential physicists found these conclusions offensive, including Albert Einstein and Max Planck. Einstein famously claimed that God does not play dice, and believed that many of the quantum theorists were making claims about the role of consciousness in physical reality that he derided as mysticism. Planck generally agreed, and, as a Lutheran, sometimes framed his perspective as the Christian one established since the Copernican and Cartesian revolution in the Enlightenment, in which religion and science were meant to deal with separate matters. A search for objective reality guided both, though religion looked for ultimate spiritual truths and science for material ones. Defenders of early mainstream quantum mechanics included Niels Bohr, who tended to reject that consciousness had any relevance to the theory, but notably wrote about the usefulness of the teachings of the Buddha and Lao Tzu in the interpretation of the theory's epistemological problems. Others, like Wolfgang Pauli, went further. Pauli was a devoted reader of Schopenhauer and claimed there might be an eventual field unification of consciousness with electromagnetism, the way Faraday had unified the electric and magnetic fields themselves 2 generations before. He cited the dharmic rejection of physical reality, alluding to the Buddhist doctrines of dependent origination, which made claims about the inherent impermanence or fluctuation of all phenomena, in contrast to a simple chain of cause and effect. Nothing other than the will or soul itself had a simple, independent identity. Interestingly, the obsession with Eastern religions appears to have been a fad, or physics otherwise seems to have adapted. There are some exceptions. In the 1970s, one physicist, Fritjof Capra, wrote a book titled The Tao of Physics, which drew parallels between modern physics and Eastern religious traditions. Capra claimed that Eastern mysticism lacked the hindrance of Cartesian duality in interpreting the new physics, and his book is cited by many as a source of the quantum mysticism now seen in New Age practices. Still, Planck observed later in life that younger physicists would not have the same philosophical struggles as his generation. Even as Bohr's interpretation became dominant, adaptations of the principles of determinism, locality, and measurement seemed to displace most need for spiritual discussion. At the very least, Buddhist and Hindu traditions may have been a starting point for moving past the simplest Newtonian worldview and reveal some of the main differences it has with the Judeo-Christian tradition on the distinction between the mind and physical reality. Even if physics has again distanced itself from philosophical or religious matters, there are still hints to their intellectual influences, from Murray Gell-Mann's Eightfold Way to the statue of Lord Shiva displayed at the CERN campus in Geneva.